Assalamualaikum everyone. So today we're going to look into the second part of IC fabrication. This is part 1 for the IC fabrication 2. In the previous class, we already see the printing process, the developing process, and then we also see the baking, the hard baking process. Okay, so the next process that will take place after that process will be etching. So if you can look into the picture inside here, there will be etching at the part where the window formed by the developing process. Okay, so and then before this one is before the etching process. After the etching process, they can be two type of etching that can be created. One is isotropic etch, usually performed through wet etching, and then another one is anisotropic etching, or we know it as dry etching. Okay, so if you look into the difference of the isotropic and anisotropic, if you can see the cut is different. Okay, so this one you can create a very straight cut. Okay, so two main types of etching: isotropic etch. So this is the isotropic etch. Etch proceed in both lateral and vertical direction, meaning that it can goes on this area, this direction, and also on the left and right direction. And for the anisotropic etch, it is a very lateral etching, so mostly it is a vertical etching. Okay, so it cut on vertical direction, so typically it is performed on dry etch. Okay, so for isotropic, it is performed in wet chemical etch, meaning it is submerged in the chemical. So this is the example of the anisotropic etching to produce the N-type Si wafer. So if you can see here is the etching area. So this one is already etched, and this is the N-type Si wafer. Now, in order for us to develop, for example, in here, we are going to develop the NPN type of transistor. So what will happen is, the next process that we need to do is, because we already have the N-type Si wafer, right? So after the etching process, so what you have to do is, we have to remove the resist, the remaining resist previously on this layer, and photoresist is then removed with dissolving chemical. Okay, so now the pattern is already transferred to the wafer. So this is the N-type Si wafer. As we already have the N-type Si wafer, so now we want to create the P part. Okay, so as for this one, we have to perform the ion implantation. So ion implantation is a process where we shoot the ion. Okay, so this is the accelerated ion. We shoot it on the Si wafer. Okay, so then it will enter through the opening on the part right here without the the oxidation layer. Okay, it will go into the Si wafer. Okay, so then it will place where it is supposed to be. Okay, so for the distance, this one, since the ion is accelerated using the electric field, which scan across the wafer surface, we can control how deep we want the ion to be going inside the Si wafer. Okay, so we'll look into this one in the next slide. Okay, so ion implantation will cause damage to the Si lattice. So after the accelerated ion enter the Si wafer, there will be some damage caused by this ion. Therefore, we have to do the heat treatment, which is the annealing, to reorder the lattice back to the monocrystalline. So in the ion implantation, the dose, which is the number of ion, can be controlled. So this one can be controlled to the dopant concentration. As for the accelerating energy, it can control the depth of the dope layer. So as I've mentioned previously, so they can control the accelerating energy so that when the ion enter, it can stop and rest on the surface where it's supposed to be. Okay, so that it not going into the N area, it will rest on the P area that we want. After the process, again we have to perform the CVD oxide layer. So this one outside layer will control the depth grown on the exposed Si. Okay, so now we want to close it back. Okay, then the process will be repeated. Okay, so this one is some of the process need to be repeated in order to create, let's say for this one we want to create NPN, so then we have to repeat to create the N on the top over here. Okay, so for example resist coating and then photolithography with different mask, and then development again, etching again. And now the ion implantation will create the N on area on this Si wafer, and then again we have to put the oxide deposition so that we can close all the part here, and then the resist coating will be performed, and photolithography with different masks will take place, and then we repeat the development and etching again. Then because we want to what we call to connect between the N, P and N together, so then it can be a circuit on the what we call on the transistor. Okay, so what you have to do, the next step will be the metallization. So if you can see here, the part will be covered with the aluminium layer deposited. Okay, so this one used to connect the individual component on the IC. So metal layer is first deposited on the entire top surface of a wafer. Okay, so first it is deposited on all of the layer, then it will be covered with the photoresist, and then the photolithography will take place in order to get the right pattern for the circuit, and then the developing will take place, and then the etching process will take place to get the what we call the very straight part here. Okay, finally the photoresist will be removed, and then what we left here is the aluminium contact, okay, on the top surface here. So then we have one type of electronic device, okay, which is the NPN transistor. So one of million of others that can be fabricated on the Si wafer. This one is just one simple transistor. You can read on this one. Okay, recall back on the electrical if you remember what you learned in the electronic or EC, electric circuit. Okay, about the transistor, the NPN transistor. Okay, if you still don't remember what is the NPN transistor, you can remember this circuit symbol. Okay, so as you already see in the previous one, that one is one simple NPN transistor that we want to create it. So in the patterning of wafer, there are a lot of photolithography masks and other processes that will take place one by one. Okay, so that's why it is very important to plan the fabrication of the Si wafer. So for better understanding also, I will suggest for you to read on this part in this article. Okay, so this is some example also to fabrication of the field effect transistor. Okay, so you don't have to submit anything. This is just a reading assignment. It's up to you. If you don't read, then it's lost for you. Okay, So take time to read and understand the fabrication process so that you will understand the process better. That's the end of part 1. We will continue with the part 2.